Assalamualaikum warahmatullahi wabarakatuh. Let's talk again about integration. In this time, we will talk about further integration, the next step of basic integration. In the previous semester, we have talking how to integrate a simple form of integration. If you find this the equation like this, yeah, when you're not meet the another variable outside the bracket, yeah, like this example, so you can actually directly integrate this form. If you remember the last semester, how to solve this integration, you just need to make a form with rule, yeah, simple rule of integration. 1 over 3 plus 1, we get 4. And then don't forget the first derivative of x plus 1 is 1. And then we can rewrite x plus 1 in the bracket, and the power changed by 4. Yeah, 3 plus 1 is 4. Okay, since the integration is definite integral, when you see the limit of integration, we are not supposed to plus c, but we rewrite the interval 1 until 3. Okay, after this, we can simplify this form. And the last part is we just have to substitute the interval. The first is above interval and followed by the bottom interval. 1 over 4, 3 plus 1 power 4 minus 1 over 4, 1 plus 1 power 4. And the final answer must be 1 over 4. 3 plus 1 is 4. 4 power 4. We get, maybe we can using calculator to get the answer. 4 power 4 is 256 minus 1 over 4. 2 power 4 is 16. It is easy. And you can simplify it first. 256 divided by 4, we get 64 minus 4, so the final answer must be 60. This is the easy form of previous topic of basic integration. We just follow the rule of simple integration. 1 over 4 is coming from 3 plus 1. 1 is coming from x plus 1. We differentiation x plus 1. Derivative of x is 1. And then followed by the bracket, and power must be plus 1. Okay, this is so simple. But in another form of integration, like this example, you cannot using simple rule of integration. Maybe you have noticed what is the difference from the first example and the second example is quite different. The second example, we meet variable outside the bracket, so we cannot using simple rule of integration. So how we can solve this equation? The step is called by substitution. Yeah, how to make substitution to solve this equation? It is quite simple. We just have to take the form in the bracket. So we can see the algebra form in the bracket is x power 2 plus 2. So just take it out. We can rewrite as u equal x power 2 plus 2. Just the algebra in the bracket. We are not use the power, or we not use the variable outside the bracket, just in the bracket. Yeah, in previous topic we call it by inner function. We just take the inner function from this integral form. After we make x squared plus 2s equal of u, we can make first derivative of u. So we get du over dx. It's mean we will differentiation u with variable x. So we get 2x and derivative of 2 is 0. We don't have rewrite 0 in this case. So we get the first derivative of u. After we get the first derivative of u, let's take a look for the other variable outside the bracket. This is the variable inside the bracket, and this is the variable outside the bracket. Okay, let's manipulate this form first. We can move dx into right side. So we need x dx, not 2x dx. We need x dx in the equation. So we have to make some step to make this form equal with this equation. From 2x dx to be x dx, we need divided by 2. So we get du divided by 2, we get half du equal, we can divide it 2 by 2, we get x, and dx, just rewrite dx because you have divided 2 in the front algebra. Yeah, okay, so we get x dx. We can rewrite this equation to be integral x squared plus 2 power 3 dx. Okay, we can substitute x power 2 plus 2 to be u. Okay, so we get new form. We get u power 3. We can substitute x power 2 plus 2 to be u power 3, and the rest is x dx. We have find x dx in the previous step. X dx is half du. So we can put du in the last term, and half in front of integral. You can put half after integral or before integral. It's okay. Okay. So let's continue the step. The integral u power 3, we get 1 over 4 u power 4 plus c, because this is not undefinite integral, because there are no interval. Yeah, different with the first example, we meet the interval of the integral. So this is definite integral, and we don't meet the interval of this integral, so this is undefinite integral. Okay, 1 times 1 is 1, 2 times 4 is 8, u power 4 plus c. maybe this is the final answer, but you have to convert u to be the origin of form of u. So 1 over 8 u to be substituted by x squared plus 2 power 4 plus c. This is the final answer for this question. Okay, let's take a look for the last example for first part of this video. Okay, as you can see in your screen, there are several integral, yeah, but there are difference of ways to solve the question. Okay, I will take the third example first. Yeah, I will take this. Okay, how to solve this integral? It is quite similar with previous example, exactly in the second example. So we have to take out the function in the bracket. So u equal x squared plus x minus 1. We don't need rewrite power 2 because we just need the equation in the bracket. After this, let's make the first derivative of u. Okay, so du over dx, we get 2x plus 1. Okay, we can move dx into the right side, yeah, or both side times by dx, so we get du equal to x plus 1 dx. Okay, this is just cosmetic. If you want to divide it by 2 or times by 3, you don't need to times the x2, yeah. Okay, let's take a look for the other variable outside the bracket. Let's check it out. 2x plus 1 dx. It is similar with 2x plus 1 dx in equation. Yeah, I think this is it was similar. So we don't have to divide it or times it with several number, yeah, because it was similar. So we can continue this this integral with substitute. So this form can be converted with x squared plus x plus 1. X squared plus x plus 1 can be substituted with u, yeah, x squared plus x minus 1 can be substituted by u. So we get new form u power 2. And 2x dx, yeah, 2x dx can be substituted by du. Okay, so we have put 1, yeah, above the fraction, yeah, because we don't have several number, so we can took 1 above the fraction, and then we can directly integrate this integral, but you have to make it u power minus 2 du, yeah, because integral cannot solve if the basic of integral is fraction. You have made it to be not fraction or product, yeah. This is integral u power minus 2 du, yeah, because u power 2 coming from in below, so we move in above, so the power must be -2. Okay, after this, let's make integral of this function. 1 over -2 plus 1 minus 1 u power -2 plus 1 minus 1. Don't forget, because it is undefinite integral, so we have put plus c in the end of the term. 1 divided by -1, we get -1. Since the power is -1, so we can move u to the below of the fraction, u power 1 plus c. So the final answer is -1 over u plus c. You have to re-substitute the u with x squared plus x minus 1. So the answer 1 over x squared plus x minus 1 plus c. Okay, this is the part 1 of concept further integration. After this, I will give you example that the substitute ways can be used to solve the equation. Yeah, we don't not every equation can be solved with substitute. Yeah, several equation can be solved by cannot be solved by substitute technique. Okay, this is second part of further integration. In the previous part, we're talking about how to integrate using simple rule of integration and how to integrate using substitution. Okay, appropriate substitution. Okay, you have seen two example about integrate with appropriate substitution. This is the first example, and this is for the second example. Okay. The core of appropriate substitution is you can find the inner bracket will be substitute with u, and the second part we find the u over the x. This is the first derivative of u, and the third part we will try to make the first derivative feel similar with the term outside the bracket. Yeah, this is the variable outside the bracket, and this is the first derivative. Okay, in the first part, after we find the first derivative of u, we get 2x. Since 2x is not equivalent with variable outside the bracket, so we need to adapt this form with divided by 2. Yeah, this is due to making similar form with outside the bracket. Outside the bracket, we need find x dx. So for getting x dx from this first derivative, we need divided by 2. Okay, so we get half du x dx. Okay, let's try to solve the other example. Okay, if you find a form like this, not all of the integration form, fraction form using substitution. Okay, let's try to solve the first example. Okay, this is after we solve the third example. Let's try to back in first example. As you can see, there are no bracket, but commonly the bracket means the more complex form. Yeah, the biggest power. Yeah, this is x squared plus x minus 1, so this is the u. Yeah, u equal x squared plus x minus 1. And for the previous example, this is x and this is x squared. So we determine that x squared plus 2 is equal u. Okay, and for in this case, so we know that u will be equal x squared plus 2x minus 3. In the second case, x squared plus 2x minus 3 will be equal with u, yeah, not x plus 1, not x minus 1. So let's try to find what is the first derivative of u in the first example and the second example. Okay, after we determine the value of u, so let's try to find the first derivative of u. The first derivative of u for the first example is 2x plus 2, and the first derivative of u in the second example is 2x plus 2. Okay, if you want to adapt this term, you have to move the x to the right side. So in the second example, sorry, it's like similar with 2. Sorry, the x must be moved in the right side. Okay, if we try to make it similar with the other term, the above term, so we can divide it by 2, so we get half du equal x plus 1 dx. And for the second example, we can divide it by 2, so we get half du equal x plus 1 dx. Okay, you find that in the second example, after we divide it by 2, we get the similar form from the equation x plus 1 dx, x plus 1 dx. This is similar. But in the first example, we are not find the similar form from the equation. We find x plus 1 dx since the equation is x minus 5 dx. This is not equal. So if you find the first derivative of u is not equal with the other term, in this case is above term, so you cannot use technique substitution for solve this question. Okay, this is can be used. Okay, so how to solve this question if we cannot using substitute technique? Maybe you can solve this by yourself after this, yeah, or we can solve it together. Let's try to solve the first one. Okay, previously we have tried to differentiate u to be du over dx. We don't get the similar term with the equation. So in this case, we need to make the partial technique. Okay, how to use partial technique to integrate this form? So the first, I will rewrite the equation, but the bottom term will be factorized to be x squared. X squared plus 2x minus 3 can be factorized with x minus 3. Plus 3 and x minus 1 dx. Okay. So the first we have to factorization the bottom form, yeah, to be x plus 3 and x minus 1. Maybe you can try to factorize by yourself. After this, we can make it apart to be x plus 3 plus x minus 1 dx, and this is a and this is b. Okay, the good way is we will try it in the other space, yeah, not in this. I think I will give it let it blank, yeah. So okay, we can break it apart to be x plus 3 and x minus 1. Okay, if you think reverse, if you find this fraction plus fraction, you will get the compound fraction or combined fraction like this. So we think it reverse for the compound fraction to be a part function. Okay, so we can use a and b, yeah. Since this is power 1, so the numerator must be constanta. If the denominator is power 2, the numerator must be power 1. Maybe in the other example we can find, oh, this is, yeah, we will try to solve this equation together. Okay, let's back to the last example. Okay, how to continue this step. We will using equivalent. Okay, x plus 3 plus b over x minus 1, so you can compound it to be x plus 3 and x minus 1, and you can cross product the denominator with numerator, so a times x minus 1, yeah. Or if you want to complex y is x plus 3 x minus 1 divided by x plus 3 is x minus 1, so a times x minus 1, and then followed by b times x plus 3. Or if you want to make it complex procedure is x plus 3 x minus 1 divided by x minus 1, it's remaining x plus 3, so b times x plus 3. Let's continue. Okay, so we get ax minus a plus bx plus 3b over x plus 3 x minus 1. Okay, so x minus 5 over x plus 3 x minus 1 equal, this is similar variable ax with bx, yeah, similar x, so we can make it to be sorry, maybe we'll be confused if I directly, okay, minus a plus 3b over x plus 3 x minus 1. Okay, we can factorize x, so we get a plus b x, yeah. This is you can let it minus a plus 3b, and this is x plus 3 x minus 1, x minus 5 over x plus 3 x minus 1. As you can see, the denominator is similar, So we can take out the numerator. The coefficient of x in the left side is 1, and the coefficient of x in the right side is a plus b. So we can make equivalency a plus b equal 1. Yeah, this is first part. Okay, and the second part, we see that minus 5 will be similar with constanta. All of them is constanta, so the constanta must be equal with minus 5, so we can make it minus a plus 3b equal minus 5. Okay, since here we can make elimination or substitution, yeah, since the a is similar coefficient, but in above is positive and in the below is negative, so we can make it plus, yeah, to cancel the variable a minus a 0, so it's disappear, and plus b plus 3b is 4b equal 1 minus 5 is minus 4, so we get b equal minus 1. This is the value of b, and to find the value of a, we can using this equation, a plus b equal 1. Since b equal minus 1 equal 1, a equal 2. So in the first, we know that x minus 5 over x plus 3 times x minus 1 will be equal with a divided by x plus 3 plus b divided by x minus 1. So since we know the value of a and b is 2 and minus 1, so we can substitute 2 and minus 1. Okay. Okay, we find the new form of this equation. Yeah, we need to do it. Yeah, it's very complex. After this, we using substitute because in this part, okay, we will do two parts in this equation. The first part is the left fraction, and the second part is the right fraction. Okay, maybe we can make it u equal, or we can back to the okay, let's using substitute for this equation. U equal x plus 3, du equal 1. Okay, du over dx equal 1 because the first derivative of x is 1. Du equal 1 dx. Since we need 2 dx, so we have to times with 2. So we get 2 du equal 2 dx. Okay, we can break it apart here like this maybe. Integral 2 over x plus 3 dx plus with minus to be minus integral 1 over x minus 1 dx. Yeah. Okay. Okay, for the right term, u equal x minus 1, du equal 1 dx, du over dx equal 1, so du equal 1 dx. Yeah, since we need 1 dx, yeah, we don't have to times by 2 or divided by 2. Yeah, we can below it. Yeah. Okay, let's continue. X plus 3 can be substituted with u. 2 dx can substitute by 2 du. Yeah, you can make it 1 minus integral x minus 1 to be u 1 minus 1 over u 1 dx to be du. Okay, maybe this is new for you. Integral 1 over u or integral 1 over x is learned. Yeah, this is the properties of integral. So if you meet 1 over u or u power minus 1, okay, this is directly can be rewrite as 2 ln u minus 1 ln u. Yeah, 1 over u is ln. Maybe if you quite not understand, you can using another variable, not u. Maybe this is u, this is v. So you're not very confused in this step. Okay, I think in the other example I will using difference variable. Okay, u for the right side means x plus 3, so we can make it x plus 3 with the with this bracket. Yeah, this kind of bracket, and this is 1 ln u is ln in this case u is x minus 1. Okay. Okay, this is quite similar with logarithm. If you want to combine this logarithm natural, you need move 2 into the back into the numerous. Okay, so we get ln x plus 3 power 2. If the coefficient move to the numerous, it will be the power minus ln x minus 1. Okay, for the final answer, you can compound ln minus ln to be ln x plus 3 power 2 divided by x minus 1. This is the final answer for the first example. Is there an equation before? You can ask me by chat room. Yeah. Okay, this is the first example. Maybe you quite confused. You can play it again. Okay, let's try to solve the second example. Since you know, we can find the above term in this case. Yeah, by divided by 2 we get x plus 1 dx, x plus 1 dx. So we can directly using substitute to solve this question. Okay, this form can be substituted by integral x squared plus 2x minus 3, x squared plus 2x minus 3 equal u. So we can substitute by u. X plus 1 dx, x plus 1 dx equal half du, berarti half du. You can using 1, yeah, for the numerator of this fraction. Okay, similar with previous example, if you find integral of 1 over u, you can directly using ln u. Okay, since it is not since it undefinite integral. Okay, okay, this is and forget to plus c in the final answer. Yeah, you have to put plus c after the sign of integral is not using. Okay, you can use plus c. Half ln u, since u is equal x squared plus 2x minus 3, so this is half ln x squared plus 2x minus 3. Okay, plus c, don't forget. Okay, this is the second example. Yeah, so if you after you find the first derivative, if the first derivative not equal with the other term, so you have using the partial technique. Yeah, this is the partial technique. You can break into two parts if you meet the fraction is two bracket. Yeah, okay. But if you after you differentiate du over dx and you get the other term, you can directly using substitute technique. Okay, let's try solve the other one. Okay, this is maybe the last example for today. After this, you can solve it by yourself. You can using this room to discuss about this integral and this integral. Yeah, let's try to using technique apart with integration. Yeah, integration with part. This is quite different with the previous example. With the first example, we can break into two parts because x squared plus 2x minus 3 can be factorized to be x plus 3 and x minus 1. In this case, we are not make it two part but three part because x minus 1 power 2 can be divided into sorry, I will rewrite the equation first. It's too long. Yeah, because x minus 1 power 2 can be divided to be itself x minus 1 power 2, and the factor can be x minus 1, and the last is x plus 2. Is there any question? I think no. Yeah, so x minus 1 power 2 can be factorized to be itself and x minus 1. So this is a, b, and c dx. Similar with the first example, we can solve it in the other space, might be in below. Yeah, this is quite small space. Yeah, okay, I will rewrite it in below but with different color. Okay, for x minus 1 over x minus 1 power 2 x plus 2 can be break out to be three part: x minus 1 power 2 plus x minus 1 plus x plus 2, a, b, c. Okay, x minus 1 power 2. Okay, you're not supposed to use to rewrite x minus 1 again because x minus 1 power 2 is x minus 1 power 2 and x minus 1 as a factor. Yeah, okay, this term divided by x minus 1 power 2 is x plus 2, so a in the bracket x plus 2 plus b, this form divided by x minus 1, so we get x minus 1 power 2 divided by x minus 1, we get x minus 1 times x plus 2. Yeah, and the last part is x minus 1 square, x plus 2 divided by x plus 2, so we get c times x minus 1 square. Okay. So we have to solve this product first. Let it x plus 2 times a, b in the bracket x square plus 1x minus 2. Yeah, you can using distributive properties. And the last term is c in the bracket x square minus 2x plus 1. You can make it x minus 1 times x minus 1. Yeah, you can using distributive properties over x minus 1 square x plus 2. Okay, this is similar, yeah. Okay, ax plus 2a plus bx square plus bx minus 2b plus cx square minus 2cx plus c over x minus 1 square x plus 2. So as you can see, we find x square. There are bx square and cx square. So we can compound it to be b plus cx square. Yeah. Let's find the variable of x. Okay, let's try to. This is x. The other is okay, and this is okay. So we can compound it to be plus a, okay, this is positive a, and plus b, and this is minus 2cx. Yeah, all of this variable followed by x. Yeah, okay, and for the constanta is 2a minus 2b plus c. The constanta is the letter without variable x. There are 2a followed by minus 2b and plus c. Okay, over x minus 1 square x plus 2. It is will be equal with for x minus 1 over x minus 1 square x plus 2. Okay, the denominator has been equal, so let's take a look for the numerator. We don't find x square in the numerator in the left side, so the conclusion is b plus c equals 0 because there are no x square in the left side. Okay, for the next term, the coefficient of x is a plus b minus 2c in the right side, and in the left side the coefficient of x is 4, so this is equal 4. For the constanta, 2a minus 2b plus c equal, this is the constanta and this is the constanta minus 1. So we have three equation: b plus c equals 0, a plus b minus 2c equal 4, 2a minus 2b plus c equal minus 1. Okay, since there are b plus c, so the first step maybe we can combine the second equation and the first equation in this. Okay, second equation and the third equation, sorry, using elimination. Okay, but the target is we will cancel a because there are no a, so this equation must be times by 2, so we get 2a plus 2b minus 4c equal 8. Yeah, because we want make it same with the third equation, which is the coefficient of a is equal to. So let's rewrite the third equation: 2a minus 2b plus c equal -1. Okay, since the variable a is equal and the sign is equal, plus and plus, so we need minus sign. 2a minus 2a 0, 2b minus 2b, 2b 4b, ya. Jadi minus mid minus 2b plus, so we get 4b. Minus 4 minus 1, so we get minus 5c equal minus mid minus 2b plus, so we get 9. Okay, we can combine this equation with this equation, so we get since we can make the coefficient of b similar, so let's try times it by 4. So we get 4b plus 4c equals 0, and for this case 4b minus 5c equal 9. Since the coefficient of b is same or similar, we can using minus. Minus times minus to be plus, so we get 9c equal 0 minus 9 minus 9, c equal -1. So we get the value of c. To find the value of b, you can using this equation or this equation. I will prefer using the simplest equation, b plus c equals 0. Since value of c -1, so b plus -1 equals 0, b minus 1 equals 0, b equal 1. I get the value of c and b. So to get the value of a, we can choose the second or the third equation. I will choose the third, yeah. 2a minus 2b plus c equal -1. Let's substitute b and c. 2a minus 2 times 1 plus -1 equal -1. 2a minus 2 minus 1 equal -1. 2a minus 3 equal -1. 2a equal -3, so we get 2, yeah. A equal 1. This is the value of a, b, and c. So we can substitute the last form of the integral. Okay, let's make it smaller. Okay, integral a is 1, so 1 over, sorry, too big, yeah. 1 over x minus 1 square plus b plus 1 plus 1 over x minus 1 plus c is -1 over x plus 2 dx. Yeah, similar with previous example, we can make it break into several parts. So we get new form 1 over x minus 1 square dx plus integral 1 over x minus 1 dx, and the last is plus, or you can directly plus mid minus to be minus integral 1 over x plus 2 dx. Yeah. Okay, for this case, okay, actually you can using the learn form, but if you confuse, let's using substitute technique, yeah. So this is u equal x minus 1, so du equal 1 dx, ya, directly aja ya. Okay, so we can substitute it by integral 1 over u square, yeah, x minus 1 is u square, 1 dx is du. Okay, you cannot integrate this fraction. You have to rewrite as u power minus 2 du. So the integral must be 1 over minus 2 plus 1 is minus 1, u power minus 1. Okay. So we get 1 divided by minus 1 is minus 1. Since the power is minus 1, so we can move u to the below u power 1. And we can re-substitute x minus 1 to be u. So we get minus 1 over x minus 1. This is the integral for the first term. For the second term, maybe we can using v, yeah. Vx minus 1, so dv over dx equal 1, so dv equal 1 dx. We can directly substitute this form 1 over v 1 dx is dv, so dv, okay, this is plus integral 1 over v is ln v. As you know, we have to resubstitute value of v to be x minus 1 ln x minus 1. Okay, ln x minus 1. Okay, let's try uvw. Yeah, w is x plus 2, so w dw over dx is 1, so dw equal 1 dx. It was similar with the equation or previous form, so we can directly substitute 1 over w, yeah, since x plus 2 equal w, 1 dx is dv dw. Okay, integral 1 over w ln w. Let's resubstitute w with x plus 2. Okay, so oh yeah, so we find two form with ln. We can compound it since the connector is negative, so we can compound it to be ln x minus 1 divided by x plus 2. Okay, and this is the final answer. Don't forget, since this is undefinite integral, so after the sign of integral disappear, you have to put plus c in the end of the term. Plus c. Okay, I think this is end of the example for today. Try to discuss this problem. Yeah, the first number you can evaluate. This is using substitute or using partial integral, and the next example is you can evaluate. This is can solve by substitute or no. Yeah, okay. Try to solve this problem. Okay, I will give you previous information to factorize this this quadratic equation. Yeah, 2x squared minus 7x plus 3. You can using this technique. Yeah, lend the coefficient of x squared to the constanta plus 6 x 6 and 1 minus and minus, since we using 2 in the first step, let's divide it by 2, x minus 3 and 2x minus 1. This is must be the factorized. If you need the factorize of 2x squared minus 7x plus 3, this is, yeah. And don't forget, and this is, yeah, you have to two question, yeah, to solve. Okay, we discuss in your class. Okay,